November 2019, paper 1, grade 10 past papers. Question number 5. The sketch below is the graph of the f of x, which is k over x plus q, and the g of x, which is x plus 2. The equation for the horizontal asymptote of f is y equals 1. Graph G cuts the x-axis at B, and graph F and G intersect at point A and point B. Question number 1, find the value of Q. Now, we know that the f of x is, let's change black. The f of x is a hyperbola because it is x as a denominator plus q. This value of q is also known as the asymptote of this equation, which means that for question number 1, q is equal to 1. That's it. We know this because it tells us that there's an asymptote where y equals 1. All right, question number 2, or 5.1.2, tells us what's the domain of f. So domain refers to all of the x values that are valid, right? If you look at the sketch, which x value is never, ever, ever included? That would be this one, right? Where x is 0. That one is never included. So x is an element of all real numbers, but x can never be 0. This is one way of writing it. Another way of writing it would be to say that x is an element of, open bracket, negative infinity until 0, curly brackets, and union or include and 0, comma, positive infinity, close bracket. Now, I just want to remind you that the curly bracket means that it does not include. If I was to draw this on a number line, I would have 0 here, and that 0 would have an open circle, and I'll have a line positive infinity and to negative infinity. Where 0 is, I have an open circle. It does not include. If I had a closed circle, let's say I had point number 2 here with a closed circle, it would be a closed circle, meaning a square bracket. Okay, so we have answered 5.1 and 5.2. Let's go 5.1.1 and 5.1.2. Let's go to 5.2. What's the equation of the line of symmetry that has a negative gradient for the f graph? Okay, lots of words. What does it mean? First of all, you have your normal hyperbolic equation. Should look like that. Your axis or your line of symmetry would be the line that goes across like this. This means that if you fold the paper on this blue line, then this point will match up with that point, and this point will match up with that point, and these lines will fold nicely on top of each other symmetrically. So under normal circumstances, your line of symmetry would be y equals x, because here it would be 0, 0, here it may be 1, 1, here it would be 2, 2, here it would be 3, 3, etc., etc. So normally it would be y equals x. But notice that on this graph, this has moved up one jump. So that means that we are simply going to add 1 over there. And that is your answer for question number 5.2.1. Your line of symmetry, oh, hold on, it's not the answer. The line of symmetry is that, but now they are complicating it and they're asking for a negative 1. So if I was to make this a negative line, this is positive, right? Meaning that my gradient goes like this. Now I'm going to change it and I'm going to make it negative. So I'm going to say y is equal to negative x plus 1. That means my gradient goes like this. So I'm drawing that line instead. And since it's plus 1, it moves up 1, so it's that line instead. All right. Next question. Take that all away. So we said for question 5.2.1, we said y is equal to negative x plus 1. What's the equation of the f of x? That one should be easy enough for you to be able to see, but all right, let's calculate. Okay, so we're going to say 5.2.2. What are we given? We are given y is equal, or the f of x is equal to k over x, and that q we have calculated as being plus 1. Now we need to choose a point to substitute into that. Now, the one thing that we know is we know point B. We know the equation for the g of x, and we know point B. If I look at the g of x, I can say that, hold on, sorry. The g of x says that g of x is equal to x plus 2. Now at the x-intercept, y equals 0. Would you agree with me? So I'm going to substitute this in there, and I'm going to say 0 is equal to x plus 2, which means that x is equal to minus 2. This is point B. Now I'm going to take this and I'm going to substitute it into that, and I'm going to say 0, because it's also, notice, the x-intercept for the f of x, right? So 0 is equal to k over negative 2 plus 1. So what do I do next? I want k alone, right? So I take the plus 1 over, so this becomes negative 1 is equal to negative k over 2. Then I multiply both sides by 2, so negative 2 is equal to negative k, and I multiply both sides by negative 1, so k is equal to positive 2. Having done all that, I can write the equation saying the f of x is equal to 2 over x plus 1. And that's the equation for the f of x. Any more questions? Yes. What are the coordinates of A, which is where the f of x equals the g of x? That's a point of intersection. So that would be, that's certain, that blue, this one. Okay. So we are going to say f of x is equal to the g of x. The f of x is 2 over x plus 1, and that is equal to x plus 2. So now what we want to do is we want to solve for x, but I have an x as a denominator. In order to do that, I am going to multiply everything by x. Okay, so I'm going to multiply this by x, and I'm going to multiply this by x. So that becomes 2 plus x is equal to x squared plus 2x. Now I'm going to move everything to one side because I have a quadratic equation. So 0 is equal to x squared. 2x minus x is positive x minus 2. Now I solve for the quadratic. I'm going to have x and x. The only factors of 2 I have is 2 and 1. And I want positive 1 in the middle. So 2 minus 1 gives me 1. Having done that, I can solve for x in two fashions. I can say x plus 2 equals 0, or x minus 1 equals 0. X plus 2 equals 0, x equals negative 2, which we know to be true here at point B, right? X is negative 2. So that's not what we want. We want point A. This is B. Here we say x equals positive 1. That's what we want. That's point A. Okay, have we solved the question? No, not yet, because we now know the x value. So now that we know that x is 1, we can take either one of the equations, but let's take the f of x equals 2 over x plus 1. Now I'm going to substitute the value of x in here, and I'm going to say y is equal to 2 over 1 plus 1, so y is equal to 3. Therefore, point A's coordinates is x is 1, y is 3. There you go. So this is how we answer the quadratic, hyperbola, straight line functions graph question. All right. Like and subscribe. See you in the next one. Bye.